After 46 years of exploration, Voyager 1 has finally broken through the ultimate barrier, the heliosphere, and entered true interstellar space. But, the data streaming back from 15 billion miles away is completely rewriting everything scientists thought they knew about the void between stars. This isn't the empty darkness we expected. The space beyond our solar system's protective bubble is alive with invisible forces, mysterious structures, and phenomena that challenge our understanding of the galaxy itself. Today, we're exploring 10 groundbreaking discoveries that prove interstellar space is nothing like we imagined. The magnetic field mystery. The first shock hit scientists when Voyager 1's magnetometer detected something completely unexpected in 2012. Instead of finding chaotic, randomly oriented magnetic fields, the spacecraft discovered that interstellar space has a surprisingly organized magnetic structure. Dr. Leonard Berlanga, from NASA's Goddard Space Flight Center, was among the first to analyze these readings, revealing that the interstellar magnetic field runs nearly perpendicular to our solar system's magnetic field. This sharp 90-degree misalignment suggests we're encountering the edge of a massive galactic magnetic domain. The implications are staggering. These aren't local phenomena but galaxy-wide structures that could influence star formation, cosmic ray propagation, and even the evolution of planetary systems. The magnetic field strength measured at 0.4 nanotesla is actually stronger than predicted, indicating that interstellar space contains more organized energy than our models suggested. This discovery fundamentally changes how we understand magnetic field interactions on galactic scales. The cosmic ray bombardment. Crossing the heliopause in August 2012, Voyager 1 immediately encountered a radiation environment that defied all expectations. Dr. Edward Stone, the mission's project scientist since 1977, watched in amazement as cosmic ray levels spiked by 300% almost instantly. These high-energy particles, accelerated by distant supernova and black holes, bombard everything in interstellar space at intensities that would be lethal to unprotected astronauts. The cosmic ray subsystem aboard Voyager detected particles with energies exceeding 100 million electron volts, radiation levels so intense they would fry electronic equipment within months. But here's the most surprising part. The cosmic ray patterns aren't random. Voyager's instruments have measured systematic variations that suggest interstellar space has natural radiation corridors and safe zones. These findings prove our sun's heliosphere acts as a far more effective cosmic ray shield than anyone realized, protecting Earth and our entire solar system from this invisible galactic storm. The plasma wave discovery. Silence doesn't exist in interstellar space. Voyager 1's plasma wave subsystem, designed by Dr. Donald Gurnett at the University of Iowa, has been detecting constant low-frequency oscillations since entering the interstellar medium. These aren't random static, they're organized plasma waves that create what scientists now call the interstellar hum. Operating at frequencies between 2 and 3 kilohertz, these waves indicate that interstellar space is filled with electrically charged particles constantly in motion. Dr. Stella Ocker, a Cornell University researcher, recently analyzed 5 years of this data and discovered that these plasma oscillations change frequency as Voyager moves through different regions. The waves intensify near density boundaries and quiet down in more uniform areas, creating an acoustic map of interstellar structure. This discovery proves that interstellar space isn't a void, but an active medium where plasma waves propagate across vast distances, potentially carrying information about distant stellar explosions, magnetic field reconnections, and other galactic events happening light-years away. The local interstellar cloud. Voyager 1 isn't just floating through empty space, it's actually swimming through what astronomers call the local interstellar cloud. Dr. Priscilla Frisch from the University of Chicago has spent decades studying this region, and Voyager's direct measurements have confirmed her theoretical models. This interstellar cloud extends roughly 30 light-years in all directions around our solar system, and contains about 0.3 atoms per cubic centimeter, which is incredibly sparse by Earth standards but still significantly denser than the cosmic void beyond. The cloud formed approximately 4 to 5 million years ago when multiple supernova explosions carved out a cavity in the interstellar medium. Voyager's instruments have detected the cloud's temperature at around 6,000 Kelvin, and confirmed it's moving relative to our solar system at 26 kilometers per second. As we drift through this cloud over the next 50,000 years, It'll gradually affect Earth's climate by modulating the cosmic ray flux that reaches our planet, potentially influencing cloud formation and atmospheric chemistry in subtle but measurable ways. The heliosphere's true shape. Everything we thought we knew about our solar system's protective bubble was, well, wrong. Voyager 1's journey has revealed that the heliosphere isn't the neat comet-shaped structure you might remember from textbooks. Dr. Merav Ofer from Boston University has been leading research using Voyager data, and her team discovered that our solar system's boundary is far more complex and turbulent than anyone predicted. The heliopause, that's the boundary between the solar wind and interstellar medium, varies dramatically in different directions. While Voyager 1 crossed this boundary at 121 astronomical units from the Sun, Voyager 2 encountered it at 119 AU, but in a completely different region with its own distinct characteristics. NASA's New Horizons spacecraft, still approaching this boundary, is providing even more data points that suggest the heliosphere might have a more irregular, possibly even fragmented structure. This discovery has profound implications for cosmic ray shielding and helps explain why the interstellar medium penetrates more deeply into our solar system than models predicted, creating these complex interaction zones where solar and interstellar forces are constantly battling for dominance. The density fluctuations. Interstellar space actually has weather, and Voyager 1 is our very first weather station beyond the solar system. Since 2013, the spacecraft's plasma wave instrument has detected at least 5 distinct density variations in the interstellar medium, each representing a different climate zone in deep space. Dr. Bill Kurth, from the University of Iowa, analyzed these fluctuations and found that interstellar plasma density can change by factors of 2 to 3 over relatively short distances. The most dramatic shift happened in 2014, when Voyager encountered a density spike that lasted several months, indicating passage through a compressed region possibly created by stellar winds from nearby stars. These variations aren't just random, they actually follow patterns that suggest interstellar space has structure on multiple scales. Some regions are compressed by shock waves from ancient supernovae, while others are rarefied cavities carved out by stellar winds. Voyager's measurements reveal that our local interstellar cloud has internal boundaries and substructures, making interstellar space far more dynamic and organized than the uniform medium astronomers once envisioned. The galactic coordinates. Every measurement Voyager 1 takes is helping scientists build humanity's first three-dimensional map of interstellar space. Dr. Nathan Schwadron from the University of New Hampshire leads the team creating these galactic coordinate systems, using Voyager's position as a fixed reference point about 15 billion miles from Earth. The spacecraft's current trajectory takes it toward the constellation Ophiuchus, where it will continue for thousands of years unless it's deflected by gravitational encounters. But Voyager isn't just traveling in a straight line, it's mapping magnetic field orientations, plasma densities, and cosmic ray gradients that, vary by galactic location. These measurements reveal that interstellar space has preferred directions and asymmetrical structures aligned with our galaxy's rotation. The magnetic field Voyager measures points toward the galactic center in some regions and away in others, suggesting complex field line geometries shaped by stellar formation and supernova events over millions of years. This galactic GPS system will eventually guide future interstellar missions, helping them navigate the invisible currents and radiation zones that Voyager is now charting for the first time. The temperature paradox. Interstellar space is simultaneously scorching hot and freezing cold, and Voyager 1 has measured both extremes. The interstellar medium itself reaches temperatures of 50,000 to 100,000 Kelvin, hot enough to vaporize any known material. Yet, Voyager's instruments register near absolute zero temperatures because the particle density is so low that there's virtually no heat transfer. Dr. Gary Zank from the University of Alabama explains this paradox. Individual plasma particles move at tremendous speeds, which means high temperature, but they're so spread out that the spacecraft actually experiences the cold of deep space. Voyager's cosmic ray subsystem has detected temperature variations in different regions of interstellar space, with some areas reaching 200,000 Kelvin, where shock waves from stellar explosions have compressed and heated the plasma. These temperature measurements reveal the energy budget of interstellar space, showing how supernova explosions, stellar winds, and galactic rotation, pump energy into the interstellar medium. Understanding these thermal processes is crucial for predicting how interstellar gas eventually collapses to form new stars and planetary systems. The communication miracle. Keeping Voyager 1 alive and transmitting from interstellar space represents honestly one of NASA's greatest technical achievements. Suzanne Dodd, Voyager project manager at JPL, oversees a mission using 1970s technology to communicate across interstellar distances. The spacecraft transmits with just 23 watts of power, less than a refrigerator light bulb. Yet NASA's Deep Space Network can still detect its whisper-faint signals after they travel for 22 hours at the speed of light. In late 2023, Voyager suffered a critical computer failure when cosmic radiation corrupted its flight data subsystem. Engineers led by Linda Spilker performed digital surgery across 15 billion miles, reprogramming 1970s computer code to bypass damaged memory sectors. The repair took months because every command required a 44-hour round trip for confirmation. By April 2024, they successfully restored communication with all 4 active science instruments. This remarkable resurrection really proves that American engineering from the space race era was built to last, giving us precious additional years of interstellar data from humanity's most distant explorer. The Golden Record's journey. Beyond its scientific mission, Voyager 1 carries humanity's greatest time capsule into eternity. The Golden Record, curated by Carl Sagan and Anne Druyan in 1977, contains sounds, music, and images representing Earth's diversity in 55 languages. Dr. Timothy Ferris, who produced the record, selected Bach, Beethoven, Chuck Berry, and traditional music from around the world. NASA engineers designed the record to survive billions of years in space, with instructions engraved in pure gold showing how to play it and how to locate Earth. The record includes greetings from President Jimmy Carter, UN Secretary General Kurt Waldheim, and children from all around the world. As Voyager travels toward the star Gliese 445, it'll make its closest stellar approach in 40,000 years, passing within 1.6 light-years of this red dwarf. Even after Earth's continents drift beyond recognition and human civilization evolves beyond imagination, the Golden Record will preserve our 1970s snapshot of humanity. Carl Sagan called it a bottle cast into the cosmic ocean, and now that bottle has reached the interstellar sea, carrying our message to whatever intelligence might someday find it drifting among the stars. Voyager 1 has shattered, well, just about every assumption about interstellar space, revealing a cosmic environment that's structured, active, and far more complex than we ever imagined. From magnetic field mysteries to plasma weather systems, this 1970s spacecraft continues revolutionizing our understanding of the galaxy itself. Voyager proves we live in a protected cosmic oasis, shielded from the harsh radiation of deep space. So, which discovery amazed you most? Drop your thoughts below. If you loved exploring these interstellar revelations, hit that like button, share with space enthusiasts, and subscribe to Future Facts for more incredible cosmic discoveries. Voyager 1, humanity's pioneering explorer, has defied all expectations since its 1977 launch. Now, more than 4 decades into its journey beyond the heliosphere, it continues revealing hidden cosmic phenomena. Recent encounters in deep space have confirmed fears long held by scientists about the unknown dangers and mysteries lurking in interstellar space, fundamentally redefining our understanding of the universe and our place within it. The birth of a star sailor. Voyager 1 emerged from an era of unprecedented ambition and innovation, conceived during the 1970s as part of NASA's ambitious Voyager program designed to explore the outer solar system. Built by the Jet Propulsion Laboratory with project scientist Ed Stone overseeing the mission direction, Voyager 1 was equipped with an advanced suite of scientific instruments specifically designed to survive the harsh environment of deep space. Launched on September 5, 1977, it embarked on what would become humanity's most audacious journey into the cosmic unknown, destined to become the first human-made object to reach true interstellar space. The spacecraft carries humanity's hopes and dreams across the galaxy, immortalized in the included Golden Record containing sounds and images representing Earth's incredible diversity. This remarkable machine, weighing just 722 kilograms, would eventually travel farther from home than any other human creation, becoming our species' first ambassador to the stars and opening entirely new frontiers in space exploration that continue inspiring generations of scientists and dreamers worldwide. The Grand Tour. The Voyager mission represented an unprecedented grand tour of the outer planets, taking advantage of a rare planetary alignment that occurs only once every 175 years. Voyager 1's carefully planned trajectory included spectacular flybys of Jupiter in 1979 and Saturn in 1980, delivering breathtaking images and groundbreaking scientific data that completely transformed our understanding of planetary science. The spacecraft's discoveries included detailed observations of Jupiter's Great Red Spot, revealing its complex atmospheric dynamics, and unprecedented views of Saturn's intricate ring system that showed structures far more complex than anyone had imagined. Each planetary encounter expanded our knowledge of the solar system's architecture while using gravitational assist to propel the spacecraft toward its ultimate destination in interstellar space. Project scientist Edward Stone marveled at how the mission consistently surpassed all initial goals and expectations, providing discoveries that revolutionized multiple fields of astronomy. The Grand Tour established Voyager as one of the most successful space missions in human history, setting the stage for even more remarkable discoveries that would come decades later as it ventured into the unknown realm beyond our solar system. The Golden Record. Voyager 1 famously carries the Golden Record, an extraordinary phonograph disc containing sounds and images carefully selected to represent Earth's incredible diversity and humanity's greatest achievements. Conceived and overseen by a team led by renowned astronomer Carl Sagan, this remarkable time capsule includes greetings in 55 languages, music from various cultures spanning classical compositions to folk songs, and natural sounds from Earth's environment including whale songs, thunderstorms, and human heartbeats. The record serves as both humanity's ultimate time capsule and our most ambitious attempt at communication with potential extraterrestrial intelligence that might someday encounter the spacecraft drifting through interstellar space. The Golden Record's ingenious design included detailed instructions for decoding its contents, with diagrams showing how to construct a record player and locate Earth within the galaxy using pulsar map coordinates. Decades later, this golden disc has become an enduring symbol of human unity, curiosity, and our deep desire for connection across the vast cosmos, immortalizing our quest to reach beyond our planetary boundaries and establish meaningful contact with whatever intelligent life might exist among the stars. Years in the void. For more than 4 decades, Voyager 1 has journeyed through the vast darkness of space, continuously transmitting invaluable scientific data as it passed beyond the asteroid belt and entered the outer reaches of our solar system. Despite traveling more than 150 astronomical units from the Sun, a distance so immense that radio signals now take over 22 hours to reach Earth, its sophisticated instruments continue functioning remarkably well, providing unique insights into space weather patterns, cosmic ray behavior, and the complex dynamics of solar-wind interactions. Mission operations at NASA's Jet Propulsion Laboratory have faced unprecedented challenges including steadily weakening power levels, extreme communication delays, and the need to manage aging systems designed in the 1970s using modern computer technology. Engineers have performed miraculous feats of remote troubleshooting, developing innovative techniques to maintain spacecraft health across interstellar distances while conserving precious power resources. Voyager 1's extraordinary longevity represents a testament to both robust engineering design and humanity's persistent determination to explore frontiers far beyond our known boundaries, proving that human ingenuity can overcome seemingly impossible technical challenges. Crossing the boundary. In August 2012, Voyager 1 achieved a historic milestone by crossing the heliopause, the mysterious boundary where the sun's influence dramatically diminishes and true interstellar space begins. This unprecedented achievement represented humanity's first tentative step into the vast galactic environment beyond our solar system's protective bubble. Scientific instruments on board detected dramatic changes in plasma density, magnetic field strength, and cosmic ray intensity, providing definitive evidence that the spacecraft had entered an entirely new cosmic environment never before directly explored by human technology. The spacecraft's signals confirmed that solar wind particles had given way to the interstellar medium, a historic validation of decades-old theoretical models about the heliosphere's structure and behavior. Mission scientist Ed Stone heralded this discovery as a triumph of human exploration, marking humanity's transition from inhabitants of a single solar system to active explorers of the broader galactic neighborhood. Subsequent measurements have continued refining our understanding of this complex boundary region, revealing unexpected turbulence and magnetic field configurations that challenge existing models. This crossing established Voyager 1 as humanity's first true interstellar spacecraft, opening entirely new chapters in space exploration and cosmic discovery. Signals from nowhere. Voyager's sophisticated instruments have detected enigmatic radio signals emanating from regions far beyond our solar system, creating one of the most perplexing mysteries in modern astrophysics. These mysterious signals from nowhere exhibit unusual patterns and characteristics that remain inconsistent with any known natural sources or previously understood cosmic phenomena. Leading the investigation into these anomalous transmissions, astrophysicist Donald Gurnett and his research team continue analyzing whether these signals originate from interstellar plasma oscillations, unknown cosmic ray interactions, or potentially even more exotic phenomena that challenge current understanding of physics. Some researchers hypothesize that these signals might result from interactions with mysterious magnetic structures, unknown particle fields, or previously undiscovered processes operating within the interstellar medium itself. The phenomenon has forced scientists to reconsider existing astrophysical models and may point toward entirely new physics operating in the vast spaces between stars. These continuing discoveries affirm that our galaxy remains profoundly mysterious, harboring phenomena that extend far beyond current scientific comprehension, and suggesting that interstellar space contains secrets that could revolutionize our understanding of cosmic processes and the fundamental nature of reality itself. The temperature mystery. Temperature measurements from Voyager 1 continue defying initial scientific expectations and creating new puzzles about the nature of interstellar space. Despite existing in the supposedly frigid environment beyond the heliosphere, instruments aboard the spacecraft have recorded unexpected temperature fluctuations and anomalously warm zones that challenge conventional models of interstellar medium behavior. Leading researcher Bill Kurth and his colleagues have analyzed extensive data suggesting complex thermal processes and unprecedented turbulence occurring in this mysterious boundary region between solar and galactic environments. These surprising findings significantly complicate existing models of interstellar medium properties, implying far more dynamic and complex interactions between particles, magnetic fields, and energy sources than previously theorized by astrophysicists. The temperature anomalies suggest active heating mechanisms that could involve magnetic field reconnection events, shockwave propagation, or entirely unknown physical processes operating on galactic scales. Understanding these thermal mysteries offers crucial insights about our sun's broader galactic environment and potential hazards that future spacecraft might encounter when venturing beyond our solar system. The discoveries underscore how much remains unknown about the cosmic environment surrounding our solar system and the fundamental processes shaping interstellar space. Changing course. Voyager 1's trajectory has exhibited subtle but measurable course changes over time, creating new mysteries about forces operating in interstellar space. These deviations appear to result from complex gravitational influences and unexpected interactions with interstellar matter that weren't fully anticipated by mission planners. Analysts at NASA's Jet Propulsion Laboratory, including project scientist Suzanne Dodd, have carefully documented trajectory deviations that cannot be completely explained by existing models of solar gravitational effects alone. The observed course changes may arise from interstellar wind pressures, gravitational effects from unseen cosmic structures, or potentially even interactions with dark matter concentrations or gas clouds drifting through our local galactic neighborhood. Continuous tracking and sophisticated data analysis provide valuable insights that inform navigation strategies and propulsion requirements for future deep space missions venturing beyond the heliosphere. These findings highlight the remarkably dynamic nature of the galactic environment and demonstrate the critical need for adaptive mission designs capable of responding to unexpected conditions. The trajectory modifications reveal that interstellar space contains forces and influences that extend far beyond current scientific understanding, suggesting that future interstellar missions will face challenges that remain largely unknown and unpredictable. Ghost in the machine. The spacecraft's onboard systems occasionally exhibit unexplained glitches and anomalous behavior that has led some mission specialists to speculate about a metaphorical ghost in the machine affecting Voyager's operations. NASA engineers continuously address these technological anomalies through increasingly sophisticated remote troubleshooting techniques, working across impossible distances to maintain spacecraft functionality. Some hypothesized issues relate to cosmic radiation impacts, gradually affecting electronic components, while others may result from normal aging processes in hardware systems originally designed for much shorter operational lifespans. The mysterious nature of these intermittent glitches adds a distinctly human element to the otherwise mechanical journey of Voyager 1 through the cosmic void. Mission engineer Linda Spilker frequently remarks on the extraordinary challenges of operating technology that's now over 4 decades old, while maintaining functionality across interstellar distances that test the absolute limits of human engineering capabilities. These technical anomalies serve as constant reminders of the spacecraft's remarkable resilience and the incredible ingenuity of the engineering teams who continue supporting its mission. The glitches also highlight how little we understand about the long-term effects of interstellar environment exposure on sophisticated electronic systems, creating valuable lessons for future interstellar mission design. Patterns within patterns. Voyager 1's continuous stream of scientific data has revealed intricate nested patterns in cosmic rays, magnetic fields, and plasma waves that researchers have dubbed patterns within patterns, complex structures that hint at deeper organizational principles operating throughout interstellar space. Leading physicist Donald Gurnett uses these unprecedented observations to develop sophisticated computer models of the interstellar medium's complex structure, revealing organizational patterns that extend across vast scales throughout our local galactic neighborhood. These nested fluctuations and systematic variations hint at turbulent cascade processes and magnetic reconnection events that may be actively shaping the galaxy's environmental conditions over cosmic timescales. The continuous analysis and interpretation of such cosmic complexity underscores the virtually endless frontier that astrophysical research represents and humanity's enduring quest to understand our place within the broader universe. Each new data transmission from Voyager reveals additional layers of cosmic organization that challenge existing theoretical frameworks and demand new approaches to understanding galactic physics. The discoveries demonstrate that even the seemingly empty spaces between stars contain rich, dynamic structures that influence cosmic evolution processes. These patterns suggest that interstellar space operates according to fundamental physical principles that remain largely mysterious, despite decades of intensive scientific investigation and theoretical development. Voyager 1's impossible encounter with the mysteries of deep space has both confirmed our worst fears and revealed profound cosmic secrets that challenge everything we thought we knew. As humanity's first interstellar ambassador, it continues providing unprecedented insights into phenomena beyond our solar system. The spacecraft's remarkable journey highlights both human ingenuity and the vast mysteries awaiting discovery in the cosmos. Which of these revelations surprised you most? Share your thoughts below. If you found this cosmic journey fascinating, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more extraordinary discoveries from the final frontier. For centuries, the moon has been a symbol of mystery and aspiration. But while pop culture and theorists debated what might be hiding on its shadowed surface, nations have been quietly racing to uncover its secrets. Recently, China made a discovery that bridges the gap between science fiction and reality, confirming that our celestial neighbor is far more dynamic and resource-rich than we ever imagined. This isn't just about rocks, it's about the future of humanity in space. Let's break down what they found and why it changes everything. Anomalous lunar structures. The notion of artificial structures on the moon has long been a fixture of speculative theories, often dismissed by mainstream science, but kept alive by intriguing images and anecdotal accounts. A key source of this speculation was the 1994 Clementine mission, a joint project between NASA and the U.S. Department of Defense. Officially, its goal was to map the lunar surface and test advanced sensors. However, the 1.8 million images it sent back contained visual oddities that have fueled debate for decades. On the moon's far side, often mistakenly called the dark side, Some of these declassified images appear to show geometric shapes and unnatural-looking formations that enthusiasts claim are evidence of broken structures or alien junk. One famous image features what looks strikingly like a pyramid, with sharp angles and a distinct shadow that seems out of place among the moon's natural craters. Theorists argue that many of these images show signs of deliberate obfuscation or blurring, suggesting an attempt to hide what was actually photographed. While scientists largely attribute these anomalies to digital compression artifacts and the play of light and shadow on a complex surface, for many, the Clementine mission was a reconnaissance effort to gather intel on something that was already known to be there. Ancient astronaut connections. The belief in lunar structures is deeply intertwined with the ancient astronaut theory, which proposes that extraterrestrial beings visited Earth in antiquity and influenced human civilization. Proponents of this theory point to various pieces of disputed evidence as proof of a continued alien presence in our solar system. One of the most cited examples is an alleged black box audio recording from the Apollo 11 mission. In this supposed transcript, Neil Armstrong is claimed to have said, "Look at those convex structures down there," describing them in a way that implies they were dome-like and artificial. While the authenticity of this quote is widely rejected and considered UFO folklore, it taps into a powerful narrative of cosmic secrecy. This narrative is further bolstered by interpretations of ancient texts, like the Sumerian tablets, which describe beings called the Anunnaki. In these stories, a god figure takes his son to the moon and tells him to wear his eagle's mask, which theorists interpret as a breathing helmet. The idea is that these ancient gods were actually extraterrestrials with advanced technology, and their masks were the helmets needed to survive in harsh environments like the moon or Mars. This connects to countless pieces of ancient art, such as the Wandjina cave paintings in Australia, which depict figures that look uncannily like modern-day astronauts in bubble helmets. China's groundbreaking discovery. While theories about ancient aliens capture the imagination, China's lunar program has delivered concrete, game-changing discoveries grounded in hard science. The nation's crowning achievement was the Chang'e 5 mission, which in December 2020 successfully landed in the Oceanus Procellarum region, drilled into the lunar surface, and returned with 1,731 grams of fresh lunar soil and rock samples. This was the first time any nation had retrieved lunar material in over 44 years. After months of intensive study by Chinese scientists, a landmark announcement was made in 2022, the discovery of an entirely new lunar mineral, named Change Site Y. This tiny, transparent columnar crystal was a monumental find, making China the third country in history, after the United States and the former Soviet Union, to discover a new mineral on the moon. But the revelations didn't stop there. Analysis of the soil samples also confirmed the presence of water, but in a completely unexpected form. Scientists found water molecules locked within tiny, soil-embedded glass beads, which were formed during the violent high-heat events of asteroid impacts. This discovery was revolutionary, proving that water on the moon was not just confined to ice at the poles, but was more widely distributed across its surface. Revolutionary implications. The confirmation of water within lunar soil has staggering implications for the future of space exploration. It is honestly the key that unlocks the concept of in situ resource utilization, or ISRU, which means the ability to live off the land. For decades, the logistics of a permanent human presence on the moon were, well, deemed nearly impossible due to the prohibitive cost of launching every necessary resource, water, air, fuel, from Earth. China's discovery changes this equation entirely. The water trapped in these glass beads, while minuscule in each particle, could amount to as much as 270 billion metric tons across the entire moon. With the right technology, rovers could heat the lunar soil to release this water vapor, which could then be collected and stored. This water could be used for drinking and agriculture in a future lunar base. More importantly, through a process called electrolysis, it can be split into its component elements, hydrogen and oxygen. This provides a source of breathable air for astronauts and, critically, the two primary components of modern rocket fuel. The moon could effectively become a celestial gas station, where spacecraft launching from Earth can refuel for missions to Mars and beyond. This dramatically reduces the mass and cost of deep space missions, making the sustained exploration of our solar system a far more achievable reality. The Chang'e program evolution. China's triumph with Chang'e 5 was not an overnight success, but the result of a meticulously planned multi-decade endeavor known as the Chinese Lunar Exploration Program. The program, named after the Chinese moon goddess Chang'e, unfolded in a series of logical, increasingly complex steps. It began with Chang'e 1, launched in 2007, and Chang'e 2, launched in 2010. These were two orbital missions that mapped the lunar surface in high resolution and scouted for future landing sites. The next phase involved landing on the moon. In 2013, the Chang'e 3 mission successfully touched down, deploying the U-2 rover and making China the third country to perform a lunar soft landing. Then, in a stunning display of technical prowess, the Chang'e 4 mission in 2019 achieved what no other space agency had ever attempted, a successful landing on the moon's far side. This historic feat required a dedicated relay satellite to maintain communication with Earth. The program's third phase culminated with Chang'e 5 in 2020. This mission showcased China's mastery of incredibly complex maneuvers, including an automated launch from the lunar surface and a robotic rendezvous and docking in lunar orbit to transfer the samples for their return journey. This steady, step-by-step evolution has, firmly established China as a top-tier space power. Resource revolution on the moon. The Chang'e 5 samples have kickstarted a complete re-evaluation of the moon's economic and strategic value, transforming it from a barren wasteland into a treasure trove of vital resources. The discovery of Change Site Y was significant not just because it was a new mineral, but because it is a phosphate mineral that contains helium-3. On Earth, helium-3 is incredibly rare, but it is abundant on the moon, having been deposited on the lunar surface by solar winds over billions of years. Scientists believe helium-3 is the perfect fuel for nuclear fusion, the same process that powers the sun. A fusion reactor running on helium-3 could provide a safe, clean, and virtually limitless source of energy, without the long-lived radioactive waste produced by current nuclear fission reactors. The ability to mine helium-3 could revolutionize energy production both on the moon and back on Earth. Beyond helium-3 and water, the lunar regolith is also rich in rare Earth elements, like neodymium, lanthanum, and yttrium, which are essential components in everything from smartphones and electric vehicles to advanced military technology. The moon therefore represents a potential solution to Earth's dwindling resources and could become the cornerstone of an interplanetary supply chain. Future lunar colonization. With confirmed access to water for life support, hydrogen and oxygen for rocket fuel, and helium-3 for energy, the dream of establishing a permanent human colony on the moon has officially moved from the realm of science fiction into the strategic plans of spacefaring nations. The ability to use local resources is, honestly, the key to sustainability. In March 2021, China and Russia capitalized on this new potential by signing a memorandum of understanding to jointly construct the International Lunar Research Station. This ambitious project envisions a permanent, autonomously operated base located at the moon's south pole, a region believed to hold large deposits of water ice in its shadowed craters. The ILRS is planned to be operational by the mid-2030s and will be a complex for scientific research, resource extraction, and technology verification. It will serve as a testing ground for the technologies needed to support human life in deep space, and act as a crucial staging point for future crewed missions to Mars. China has even floated the idea of building a nuclear power plant on the moon by 2028, to provide the substantial energy required for the base's long-term operations, demonstrating a clear and determined vision for lunar colonization. Lunar resources, the new gold rush. The scientific confirmation of vast and valuable resources on the moon has, ignited a 21st century gold rush, sparking some pretty intense geopolitical competition for control over lunar territory and its riches. The economic implications here are just enormous. The ability to mine water, helium-3, and rare earth elements could, honestly, create entirely new industries and shift the global balance of power. This has turned the moon's south pole into probably the most desirable real estate in the entire solar system, as its permanently shadowed craters are thought to contain massive, accessible deposits of water ice. However, this frantic race to the moon is unfolding in, a legal gray area. The 1967 Outer Space Treaty, which is basically the foundational document of space law, clearly states that no nation can claim sovereignty over any part of a celestial body, but the treaty is, pretty silent and ambiguous on the issue of resource extraction by commercial or state entities. It does not explicitly prohibit mining, nor does it establish a clear framework for who owns the resources that are extracted. This legal vacuum is creating a high-stakes environment where nations are rushing to establish a presence, a sort of facts-on-the-ground precedent, to bolster future claims to lunar resources. International space race. The modern space race is, well, a multipolar and multifaceted competition, and it's really starkly different from the old two-nation Cold War rivalry. In one corner stands the United States, which is pursuing a return to the moon through NASA's Artemis program. The program's stated goals are to land the first woman and first person of color on the lunar surface, and to establish a sustainable, long-term human presence. A key feature of the Artemis program is its deep reliance on commercial partnerships. Instead of building all its own hardware, NASA has contracted private companies like SpaceX to develop the Starship human landing system and Blue Origin to build a second lander. This public-private model aims to foster innovation and reduce costs by leveraging the dynamism of the commercial space industry. This approach is actually codified in the Artemis Accords, a set of non-binding principles for safe and transparent lunar exploration. The accords have been signed by dozens of countries, creating a pretty broad US-led coalition. This collaborative yet commercially driven strategy represents a fundamentally different philosophy from the state-controlled programs of its main rivals, and it's really setting the stage for a new era of exploration, defined by competing models of international cooperation. Competition between China, US, and other nations. The new race to the moon is honestly increasingly defined by two major competing blocks. On one side is the US-led Artemis Accords, which brings together established space powers like Japan, Canada, and the European Space Agency, along with emerging space nations, under a common framework for lunar governance. On the other side is the China-Russia Alliance for the International Lunar Research Station. While this partnership is currently smaller, it is actively recruiting other nations, with countries like Pakistan, the UAE, and Venezuela having signed on. This creates a clear geopolitical divide, extending terrestrial rivalries right into the celestial sphere. However, it's not strictly a bipolar race. Other independent players are making significant strides. India's space agency, ISRO, achieved a major triumph in 2023 with its Chandrayaan-3 mission, which successfully landed a rover near the lunar South Pole, a historic first. This really demonstrated India's growing capabilities and its intent to be a key player in lunar exploration. The landscape is a complex tapestry of national ambition, commercial interests, and strategic alliances, where intense competition is the primary driver of innovation, but the immense challenges of space may ultimately necessitate cooperation between these rival factions for humanity to truly establish a permanent foothold on the moon and beyond. From mysterious anomalies to game-changing mineral discoveries, the moon has, once again, captured the world's imagination. It's no longer just a silent, barren world, but a frontier of immense scientific and strategic importance. China's recent findings have accelerated a new era of exploration, pushing humanity to answer some pretty profound questions about our past and our future in the cosmos. So, what do you think is hiding on the moon? Let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the future of science and technology. Thanks for watching Future Facts. In the vast expanse beyond our solar system, the realm of interstellar space challenges our understanding of the cosmos. From the familiar faces of planets like Earth, Mars, and Jupiter, humans have long dreamed of what lies beyond. The heliopause, the boundary where solar influence ends, marks the start of true interstellar space. Since Voyager 1 crossed this threshold in 2012, revealing complex magnetic and plasma phenomena, astronomers have tracked enigmatic visitors like Oumuamua in 2017 and Borisov in 2019. Now comes the mysterious visitor, 3I/Atlas, promising to deepen our cosmic perspective. Beyond the heliopause, our interstellar visitors. Beyond the heliopause lies a vast territory filled with rarefied plasma, cosmic dust, and magnetic fields shaped by the galaxy. The solar wind's protective bubble ends at roughly 121 astronomical units, where Voyager 1 provided unprecedented data on the transitions between solar and galactic environments. This region, once thought to be sterile, teems with dynamic phenomena including plasma waves, magnetic reconnection events, and cosmic ray interactions that alter our view of cosmic landscapes. Dr. Ed Stone, Voyager's project scientist, noted that crossing into interstellar space revealed an environment far more complex than anticipated. Interstellar visitors like Oumuamua and Borisov offer rare glimpses into this frontier, acting as natural probes from distant star systems to ours. These objects carry information about stellar formation processes, planetary system evolution, and galactic chemical composition that would otherwise remain inaccessible. Their study has revolutionized our understanding of material exchange between star systems, revealing the dynamic nature of our galactic neighborhood. The third visitor, 3I Atlas discovery. 3I/Atlas was first detected by the Asteroid Terrestrial Impact Last Alert System in early 2025, marking a historic moment as humanity's third confirmed interstellar visitor. Astronomers worldwide scrambled to confirm its hyperbolic trajectory, ensuring it was genuinely from beyond our solar system rather than a long-period comet. Its approach from the constellation Lynx at extraordinary velocities immediately marked 3I/Atlas as a unique opportunity for scientific study. Dr. Robert Warwick from the University of Hawaii, who also discovered Oumuamua, led early observations confirming its strange orbital parameters and unusual characteristics. Unlike its predecessors, 3I/Atlas displayed continuous cometary activity and potentially larger size, intriguing scientists worldwide who aim to unlock its secrets before it disappeared forever. Initial spectroscopic observations revealed complex chemical signatures suggesting a composition unlike typical solar system comets. The discovery triggered an international observation campaign involving major telescopes across 6 continents, demonstrating the global cooperation essential for studying these rare cosmic visitors. A hyperbolic journey at 58 km. The Atlas survey system, employing wide-field telescopes in Hawaii and Chile, represents cutting-edge technology designed to detect potentially hazardous near-Earth objects. Its success in capturing 3I/Atlas demonstrates how advanced algorithms optimized for fast-moving objects can identify interstellar visitors among millions of routine asteroid observations. Dr. Larry Deneau, who leads the Atlas project, explained that the system's 4-telescope network scans the entire visible sky multiple times each night, creating a comprehensive catalog of moving objects. The detection of 3I/Atlas required sophisticated orbit determination software capable of distinguishing hyperbolic trajectories from elliptical ones. Atlas's rapid response capabilities provided crucial early warning, enabling astronomers to begin intensive observations months before the object's closest solar approach. The system's real-time processing algorithms automatically flagged 3I/Atlas as anomalous based on its velocity vector and trajectory characteristics. This breakthrough exemplifies how technological evolution enables rapid response and detailed tracking of transient cosmic visitors, expanding humanity's reach into the unknown. From A11PL3Z to C2025N1, the naming journey. The naming journey follows established astronomical protocols. When the object was first detected, it got the provisional designation A11PL3Z, which marks it as an asteroid-like object discovered in the second half of 2025. After astronomers confirmed its cometary activity through spectroscopic analysis, it was reclassified as C/2025N1, which means it's a comet discovered in July of 2025. The International Astronomical Union then assigned the official prefix 3I/, marking it as the third confirmed interstellar object after Oumuamua, 1I/, and Borisov, 2I/. The name Atlas honors the Discovery Survey System, following IAU traditions of crediting the discovering institution. Dr. Gareth Williams, director of the Minor Planet Center, oversaw the naming process, which really balances the need for rapid identification with conventions that reflect astronomical heritage. The provisional to permanent designation pipeline usually takes several months, as astronomers need enough observational data to confirm orbital characteristics. This systematic approach helps prevent misclassification and make sure proper credit is given. The naming process also reflects international cooperation in astronomy, since discoveries made by one team benefit the whole scientific community. Committee guidelines are in place to ensure that names remain scientifically appropriate while honoring significant contributions to astronomical discovery. Brightness, rotation, and the 29-hour cycle. 3I/Atlas follows a hyperbolic orbit traveling at about 58 kilometers per second relative to the Sun, which means it's on a one-way trip that will never return to our solar system. Its path cuts through the ecliptic plane with impressive precision, bringing it within gravitational reach of major planets like Mars, Venus, and Earth. Orbital calculations by Dr. David Farnokia at NASA's Jet Propulsion Laboratory show that this object's path creates several planetary encounters, which will slightly tweak its trajectory through gravitational assists. The perihelion passage on October 30, 2025, is the best time to observe it, as it comes within 1.2 astronomical units from the Sun. Scientists like Dr. Alan Fitzsimmons are looking at how these gravity-influenced changes in trajectory can teach us about interstellar dynamics and how planetary systems interact. The approach geometry actually allows observations from both hemispheres as it moves from the southern to the northern skies. Computer simulations predict that these gravitational encounters will speed up 3I/Atlas by a few kilometers per second, showing how our solar system can act like a gravitational slingshot for interstellar objects. Coma tail and cometary activity. Observational campaigns show that 3I/Atlas measures somewhere between 8 and 15 kilometers in diameter, making it quite a bit larger than Oumuamua, but about the same size as Comet Borisov. Light curve analysis by Dr. Karen Meach at the University of Hawaii suggests a rotation period of around 29 hours, which might mean it's a slow rotator, or maybe even has a complex tumbling motion. The object's brightness variation suggests it's not a perfect sphere, maybe elongated like Oumuamua, but not as extreme. Unlike most comets, 3I/Atlas has a persistent but faint coma, and doesn't develop a pronounced tail, even as it gets closer to the Sun. Spectroscopic studies led by Dr. Bin Yang from the European Southern Observatory have found complex mixtures of water ice, carbon monoxide, and organic compounds in its makeup. Its unusual reflectivity patterns hint at surface materials that are different from typical solar system comets, possibly pointing to its formation in a completely different stellar environment. Thermal modeling shows that 3I/Atlas holds onto internal volatiles that start to sublimate at greater distances than we'd expect, which is what creates its unique cometary activity. Oumuamua versus Borisov versus 3I/Atlas. Comparing these three confirmed interstellar visitors, we see, honestly, just remarkable diversity in the cosmic debris traveling between star systems. Oumuamua, which was discovered by Dr. Robert Warwick back in 2017, still remains an enigma with its extreme cigar-like shape, and that unexplained non-gravitational acceleration that, well, defied conventional comet behavior. Comet Borisov, found by amateur astronomer Gennady Borisov in 2019, actually behaved like a typical comet, with visible coma development, active outgassing, and familiar spectroscopic signatures. Now 3I/Atlas kind of occupies the middle ground, displaying characteristics that bridge both previous visitors, while also introducing entirely new complexities. Dr. Olivier Haynaut notes that 3I/Atlas shows controlled outgassing patterns and variable brightness that, frankly, just don't match traditional comet models. Statistical analysis by Dr. Alan Harris suggests these three objects represent different formation environments and evolutionary histories. Oumuamua's rocky composition contrasts sharply with Borisov's ice-rich nature and 3I/Atlas's hybrid characteristics. The growing sample indicates that interstellar space contains diverse populations of objects ejected from planetary systems during their formation phases. And Dr. Michelle Bannister emphasizes that only through multiple observations can patterns emerge, revealing the vast variety of interstellar debris shaping galactic material exchange. A 311-billion-year-old traveler. Radiometric dating techniques applied to spectroscopic data suggest that 3I/Atlas could be anywhere from 3 to 11 billion years old, potentially predating our solar system's formation by billions of years. Dr. Dante Loretta from the University of Arizona is leading the research into the object's age determination, using isotopic ratio analysis from remote spectroscopy. Its composition seems to retain primordial chemical markers from ancient star-forming regions, with metallicity signatures that are distinct from materials found in our solar system. The object's surface spectral features indicate the preservation of materials that formed in environments with different stellar winds, radiation fields, and chemical abundances than those that shaped our local planetary system. Computer modeling by Dr. Alessandro Morbidelli suggests that 3I/Atlas likely originated from a red dwarf system, where different thermal and gravitational conditions prevailed during planetary formation. This extreme age, paired with the object's unexpected structural integrity after eons of cosmic ray bombardment and micrometeorite impacts, really challenges our current models of how interstellar objects survive such extended journeys. The preservation of volatile compounds over geological timescales raises some intriguing questions about protective mechanisms or internal heating that could maintain structural stability across galactic distances and timescales. October 30th, perihelion and beyond. The perihelion passage of 3I Atlas on October 30th, 2025, provides the optimal observation window before it begins its eternal journey back to interstellar space. Major facilities including the Vera C. Rubin Observatory, Keck telescopes, Very Large Telescope, and the Hubble Space Telescope will conduct coordinated monitoring campaigns during this critical period. Dr. Lynn Jones from the University of Washington is coordinating the legacy survey of space and time observations that will track the object's brightness evolution and spectral changes as solar heating intensifies. Scientists are anticipating the chance to gather unprecedented data on volatile sublimation patterns, dust production rates, and internal structure through radar observations from Arecibo and Goldstone. The James Webb Space Telescope will attempt infrared spectroscopy to identify organic molecules and isotopic compositions that are invisible to ground-based instruments. Dr. Heidi Hammel, Webb's interdisciplinary scientist, expects these observations to provide definitive answers about 3I Atlas's formation environment and evolutionary history. Following perihelion, the object will fade rapidly as it recedes, making these next few months humanity's only chance to unlock its secrets. The Future Hunt. From beyond the heliopause, 3I Atlas joins Oumuamua and Borisov as rare interstellar messengers that expand our understanding of galactic material exchange. Each visitor challenges existing scientific models, while also driving technological innovations in detection systems, rapid response observations, and international collaboration protocols. The Vera C. Rubin Observatory, which is set to begin full operations in 2025, promises to detect dozens of similar objects every year, transforming interstellar visitor studies from rare events into routine observations. Dr. Mario Jurek from the University of Washington predicts that within a decade, astronomers will catalog hundreds of interstellar objects, enabling statistical studies of their population characteristics and origin distributions. These cosmic messengers carry information about stellar formation processes, planetary system architecture, and galactic chemical evolution happening all across the Milky Way. Advanced survey telescopes like NEO Surveyor and LSST will totally revolutionize our ability to detect and track these visitors, providing early warning for detailed study campaigns. The growing census of interstellar objects will help answer fundamental questions about the universality of planetary formation, material ejection mechanisms, and the prevalence of organic compounds in other stellar systems, potentially reshaping our understanding of life's cosmic context. The journey of 3I Atlas through our solar system really reveals the dynamic nature of our galactic neighborhood, where ancient travelers carry secrets from distant worlds. Each interstellar visitor expands our cosmic perspective and challenges our understanding of planetary formation across the galaxy. As advanced survey systems prepare to detect many more such objects, we stand on the threshold of a new era of interstellar archaeology. Which aspect of 3I Atlas fascinates you most? Share your thoughts below. If you enjoyed this cosmic journey, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible discoveries.